All right, now we're going to have a look at the problems here. So problem number 2 on this handout, we're told that the lines with equations ax minus 2y is equal to c and 2x plus by is equal to negative c are perpendicular intersect at the point negative 1, 5, or 1, negative 5, and then we just go from there. Okay, so let's start putting things together. So in this case here, the important information is the fact that they're perpendicular, and they also intersect at the point 1, negative 5. So that's going to be useful information to us. Since they're perpendicular, we know the slopes are going to multiply to negative 1. So I'm going to go ahead and rewrite these equations so I can figure out what the slopes are. So you have ax minus 2y equals c. So we're going to isolate the y here. So you get negative 2y equals negative ax plus c. So y equals, we divide everything by negative 2, we get a over 2 times x minus c over 2. Okay? And now we do the same thing for the other one here. We can do this here. We get 2x plus by equals negative c. So you get by equals negative 2x minus c, and therefore y equals negative 2 over b times x minus c over b. Now again, I don't really care about these terms here, the y coordinates, the y intercepts. We're not really too big on this. We'll just care about these. So according to this, we have, since these are, we can take the slopes, we have a over 2 times negative 2 over b, and that's equal to negative 1 since they're perpendicular. Now the nice part is that the 2 and the negative 2 cancel out here, so I get negative a over b equals negative 1. If I multiply both sides by b, I get negative a equals negative b, which implies that a equals b. That's a huge bit of information. So now we have a equals b. Now we have to use the other information. They intersect at the point 1, negative 5. Since they intersect at the point 1, negative 5, this means that 1, negative 5 satisfies both these equations simultaneously. So therefore, we can go back and do this. So I'm going to go ahead and substitute things in here. So in our first situation, we get a times 1 minus 2 times negative 5 equals c. And in the second one, we have, so let me just go ahead and set this up here. So we get a plus 10 equals c. That's a useful bit of information. And then from the other one, we have 2 times 1 plus b times negative 5 equals negative c. So you get 2 minus 5b equals negative c as well. Okay? So note that in this situation, we now have two equations here. We also know that a is equal to b. So now I can sort of put this all together here. Since these are the same here, one's the negative of the other, I can just set these equal to each other. We have a plus 10 equals the negative of this, negative parentheses 2 minus 5b. Now also note that a equals b, so I can swap that in here as well. That's negative 2 minus a minus 5b is a positive 5b, but b is equal to a, so I can write this as a positive 5a here. So you can go ahead and set this up, do your algebra here. You get negative 4a equals negative 12, so a is equal to 3 here. And that's also b. And now c is just a plus 10, so that is 3 plus 10, or 13. Now problem 3 is a little easier. This one here is just sort of a combination. Suppose that two lines L and M have equations of these. When k is a, lines are parallel. When k is either perpendicular, let's compute a plus b. This is pretty straightforward here. This is a lot easier than problem 2 because we can just simply extract the slopes. So in this case here, the slope is negative 2, and the slope here is k plus 1. So now we can put them all together. Now, when they're parallel, we know they're going to be equal. So the parallel case here is going to be negative 2 equals k plus 1. That implies that, I believe, it looks like we can subtract 1 from both sides. So you get k equals negative 3, and that gives us a here. Okay? When they're perpendicular, on the other hand, the product is negative 1. So negative 2 times k plus 1 equals negative 1 here. So you can divide both sides by negative 2 here. It looks like you get k plus 1 equals 1/2 here. So k is minus 1/2, and that's b. So it's pretty clear that a plus b is just negative 3 minus 1/2, which is negative 3.5, or negative 7/2 here. Okay. Okay, now let's go to problem 5. So the y-intercepts P and Q of two perpendicular lines intersecting at the point A, 6, A have a sum of 0. What is the area of APQ? So as always, let's draw a nice picture of this here. So here's my picture. There's a lot of different ways that you can do this problem here. Okay. Now, the important piece of information. We have perpendicular lines, they intersect at the point 6, 8, and they have a sum of 0. So that last part is the most interesting to me, the fact they have a sum of 0. Since they have a sum of 0, this means that the two y-intercepts have to be sort of on opposite sides of the x-axis, and in fact they have to be reflections of each other, right? So if one of them is like 2, the other one's negative 2. One of them is 6, the other one's negative 6. So we can call the two intersection points here k and negative k. So I'm going to go ahead and label that here. So this is one intersection point here. So let me call this point here P. This is the point 0, comma K. The other intersection point is going to be down here. This is going to be the point 0, comma negative K, where K is some positive number that represents the y-intercept here. Now we can go ahead and sketch our lines. So here's our line like this. I'm just going to do a quick sketch of this line here. And then we have a perpendicular line like so, like this. Again, I apologize, my diagram isn't that scale, but we have A here, and that's 6, comma 8. So now we're looking at this triangle PAQ. Now, remember that the area of a triangle is just 1/2 the base times the height, and we have a very nice base here. This base PQ looks pretty good, and in this case here, we just need to find the length of a value of K, because then the base is just 2K here, and the height is just the segment perpendicular to it. How fortunate that this is a vertical line, so that means the height here is just this horizontal distance, which is 6. So, the only piece of information we haven't used yet is the fact that the lines are perpendicular, which means we're going to be looking at slopes. Let's have a look at the slopes here. So if we look at the slope of AP, we know the slope of AP here is going to be, again, we just set it up. So we have K minus 8 over, looks like K minus 8 over 0 minus 6, which is just K minus 8 over negative 6 here, okay? So we'll keep that there. If we look at the slope of AQ, on the other hand, we look at the slope here, and then we get negative K minus 8 over 0 minus 6 again. So we get negative K minus 8 over, so negative K minus 8 over 0 minus 6. Okay, so we do the same thing here. We get that. So we note that in this situation here we have this. Now we know the product of the slopes is negative 1. So we're going to have to go ahead and set that up here. So we know that the the slope of AP times the slope of AQ is negative 1. So I'm going to have to go ahead and set this up. Therefore, we have K minus 8 over negative 6 times minus K minus 8 over negative 6. And that's negative 1 here. Okay. So what a weird thing. All right. I guess one of the things we can do here is I'm going to multiply both sides by a positive 36 here. By multiplying both sides by positive 36, we end up with this sort of thing here. We clear the denominators here. So I get K minus 8 times negative K minus 8 equals negative 36. I just multiply both sides by 36. So what I find really weird is that these numbers look very similar to one another. In fact, I can probably do something with this here. There's a minus K and a minus 8 here, so I can yank out a minus 1. There's a negative 1 that's a common factor to both. So I can do K minus 8 times, if I pull out the negative 1 from here, yank out the negative 1, that negative K becomes positive, the negative 8 becomes positive, so you K plus 8 here. Now that negative 1 has nowhere to go. That negative 1 actually can cancel out with the negative 1 on the right-hand side. The right-hand side has a negative 36 here, so I can divide by negative 1 on both sides, and we end up with 36 here. Now, how convenient that we have K minus 8 times K plus 8 is 36 here. That actually works out really well. This is just a difference of perfect squares. This K squared minus 64 is 36. So you get K squared is 100, and therefore K is equal to 10. Or, well, technically plus or minus 10, but note that in this situation here, we let K be a positive number. If K is a negative number, then the picture's actually flipped upside down, but it really doesn't matter that much, okay? So we have that sort of situation here. So now we can find the area of the triangle. So therefore, the area of the triangle, APQ, is just 1/2 times 6, which was the height that we had, times this entire length here. And since we know that K is 10, we know this has a length of 20. So therefore, it is 1/2 times 6 times 20, and therefore the area is 60.